Hello and good morning. So today we are going to look at the domain and range of polygons on a coordinate plane. And this is going to be listed in interval notation, which is one of the notations that we looked at yesterday on our notes. So we took notes yesterday on what domain and range is and the different ways it can be given to you and you might see it. And so today I wanted to look at how we can find the domain and range of different polygons. So we've been looking at polygons, finding the area and the perimeter of different shapes, but you can also find what the domain and range is if they're on a coordinate plane, which is basically just how far on the y-axis do they touch, how far on the x-axis do they touch. And so we're going to use our shading technique that you saw in the notes yesterday and figure this out. So the notes are listed below, and if at any time I'm going too fast, you can pause the video. But we are going to find whatever it is asking us to find down here for each polygon. So for polygon number 1, and I'm going to color coordinate mine with the color I wrote in, it's asking us to find the range. And you'll notice I've already written the notation for you, but I want you to realize if it's asking us for range, the letter in the middle is Y. If it's asking us for domain, the letter in the middle is X. And we always have to have these symbols because the Y value, whatever our polygon Y values are, have to be greater than this small number, but less than this big number. So it has to have this notation to make sense. So let's look at number 1. So for polygon number 1, it wants us to find the range. So we're going to go up here and find the polygon that has the number 1 inside of it, which is this one. And I wrote range beside my Y and domain beside my X to help me remember that the X-axis is domain, the Y-axis is range. So for this polygon number 1, it wants us to find the range, or how far on this y-axis does this polygon cut through. So you're going to go to the furthest point up, and I like to just draw a line, and then the furthest point down, and also draw a line. And then I just shade everything in between. So I do like this, and I say, okay, what numbers on the y-axis does this polygon cut through? If I shade everything, including the polygon, so there's no point of this polygon that's left out of the shade, it shades all the way up to 5 and all the way down to 1 on this y-axis. It's covering those numbers, 1 through 5. So 1 and 5 are the two numbers that this polygon is going up to. So when I come down here and I write this, remember the smallest number goes here, the biggest number goes here. So I'm going to write a 1 here and a 5 here. So the range of this polygon is between 1 and 5 on the y-axis. Simple enough. Let's look at the second one. So it says, what is the domain of polygon number 5? So we're looking at x values. What is the domain, or how far on this x-axis is this polygon going to touch? So we need to come back up here and find polygon number 5, which is this one. And if it wants to know the domain, I'm not looking to see what it cuts through on the y-axis. I don't need to draw lines over to the y-axis. I need to cut through this x-axis down here. So I need to draw lines from the furthest points on this polygon down to my x-axis. Same thing, how far over does it go on this side? It goes over to there. And then just shade in the middle, as long as every part of that polygon gets shaded. Okay, so on the x-axis, or the domain of this polygon, how far to the left and to the right does this polygon move? Well, if we look at our x-axis, it's going from -5 to -3. So that would be the domain of this. Now we're going to go from the smaller number to the bigger number. This is tricky though, because -5 is it's a bigger number, but it's smaller than -3. Okay, because it's even less of a number than -3. If these are real numbers, then the more negative you get, the further away from a number you are. So this is even less of a number, and this is a little bit more of a number, a little bit closer to. So when we do this, we go from -5 to -3. So it's x's that are greater than -5 but less than -3. So when we look, anything greater than -5 but less than -3. So anything in between those two. Now let's see what the next one wants of us. Find the range of polygon number 3. So the range is my y values of polygon number 3. That's right here. Y values means I need to be looking on this y-axis. I need to be saying, okay, if I were to take the furthest points on this polygon and come over and touch my y-axis, where would I be cutting through? So I've got this point on the y-axis, and then, if you want to do every single point, you really can. Here's another point, here's another point, and another point. Now I need to shade so that the whole polygon is shaded. All the way down to that furthest point. So the whole polygon is shaded, and I made sure to go over to my y-axis because we're looking for range. So what are the numbers it's in between? Also 1 and -3. So these are the two numbers that this polygon is in between. The range of this polygon is between 1 and -3. So we're going to go from the smallest number to the biggest. So this is less than a number, less than a whole number, and then 1 is a whole number. So I know that when you're physically looking at these numbers, you're thinking, well, 3 is bigger than 1. This is a -3. So if you think about it as money, if you have -$3, that's a lot less money than $1, right? You're in the hole. You actually owe somebody. So this is actually less than this. Same reason why -5 was less than -3, because it was further away from 0. It was even less money, if you want to think about it in money terms. So if we have 1 and -3, when we fill this in, the -3 is smaller and the 1 is bigger. So anything between -3 and 1, as long as your y is bigger than -3, so anything up here, bigger than, but less than 1, so everything below 1. So in between these two, the interval between these two numbers. Good job. Okay, let's look at polygon number 2. So it says find the domain of polygon number 2, which means we're going to be looking on the x-axis for polygon number 2. So for polygon number 2, it's right here. I need to be cutting through the x-axis. So I need to draw lines down to the x-axis. And again, these are just sketched lines. I don't want you guys to worry about them being perfect. And I need to see what is the interval that this polygon, if I were to scoot it down, what would it touch on the x-axis? So I'm just going to shade in so I can see. The shading helps me visually see what this polygon is cutting through. If I shade as wide as the polygon, then if I were to shift this down, it would hit these two numbers. So the interval that it's cutting through on the x-axis, or the domain of this polygon, is between 3 and 5. And 3 is a smaller number than 5. So when we write this down, we put 3 here and 5 here. So as long as my x is greater than 3 but less than 5. And it can be equal to those numbers, because as you see, it does touch those numbers. So all of these are equal to that number, but anything in between. And then the last one that we have is the domain of polygon number 4, which looks to be similar to another one. So if this is polygon number 4, the domain is talking about the x-axis. So if I were to extend this up to the x-axis and shade, make sure the whole polygon is shaded. I'm going as wide as the polygon. I'm going to go to -5 and -3. That's as wide as this polygon is going to go. So those are the x values it's going to cut through. So it's the exact same as number 5 was. It's just down below. So again, just like earlier with polygon number 5, -5 is a smaller number than -3. It's even less of a number, so to speak. And so that is interval notation for domain and range. So if it is range that we're talking about, the letter in the middle is y. If it is domain that we're talking about, the letter in the middle is x. You will always have these symbols, meaning that any y value or any x value in between these numbers can be included. So for example, if we look at polygon number 1, it says when your y value is greater than 1 but less than 5, or any y value in between 1 and 5. Well, if we look at polygon 1, if I have a y value of 1, I'll be touching this polygon. If I have a y value of 2, I'll be touching somewhere on this polygon, either over here or over here. A y value of 3, I'll be touching here or here. A y value of 4, I will be touching here. And a y value of 5, I will be touching here. So there is a point of this polygon at every single number between 1 and 5 that I would be touching. Now, if I said a y value of 0, there's no way that this y value of 0 is ever going to touch that polygon. It's right here. It's too low. And a y value of 6 is too high. I'm never going to touch the polygon. So anything between 1 and 5, you will touch some part of this polygon on the y-axis. And so that's why we notate it this way, because instead of writing all of the numbers, we can simply say any y value in between 1 and 5 will work for this polygon. Same thing for the domain. And another way that you could write this, so for example, I'm just going to show you this. This notation is just a simple way of writing two different sets all together. So this is x is greater than or equal to -5, and this one is x is less than or equal to -3. Okay, so you see how the x has the opened side of the symbol facing it, and it's pointing towards the -5. Same thing here. It has the open side to it, and it's pointing to -5. Over here, the x has the closed side to it, and it is open to -3. Over here, x is open to -3. So I could say anything where x is greater than or equal to -5 and also less than or equal to -3. Or I can literally take this right here and flip it so that it's mirrored and the x is in the middle and just write it one time, which is what we do here. So this is just a fancy way of writing two separate notations all together. And we can say any x value in between these numbers, or any y value in between these numbers. And you have to make sure that those symbols are facing the right way. I think that, to me, they always look like L's. So if they don't look like an L, you've done it wrong. Also kind of looks like an eye, a nose, and an eye. Kind of. So this is your notes for today and how you find domain and range of polygons, and we will work on that the next time that you are in class. So make sure that you get this copied down and you don't have any questions. If you do, as always, feel free to YouTube or look up other resources or email me and we can set up a Zoom. Good job today, guys.